So there are certain results in physics that we actually want to memorize, and one of those is, sure, there are contact forces among blocks here in this system, but it turns out the acceleration of the blocks can actually be found by taking the force applied and dividing it by the total mass. And in this case, we're going to have 6 times 2 is F, and that's how we're getting 12 newtons. All right, now for number 8. An object falls at 9.8 meters per second squares. What does this mean? What it means is that it gains speed at this rate. None of these other things are true. This is definitely not true. Definitely not true. This is a distractor, and I don't know what this is. It's wrong. I think it falls like 4.9 in the first second. All right, now for number 9. Ew. So the velocity of a particle moving along the x-axis is a function of time. And we want to get the acceleration. Let's do the calculus. Ew. Okay, so A is going to be v dot, the derivative. So we're going to get 6t minus 2 plus 0 when we take our derivatives, when we derivatize. So that's going to be 6 times 2 minus 2. I'm getting 10 meters per second squared. Meow. Good for me. All right. Now an object is dropped from the top of a cliff. So a lot of people, I saw them do this. They said x is 1/2 times negative 10 times t squared plus 400, and that's totally cool. If you do that, you're going to end up getting x is 220 meters. And then you're like, wait, that's not on there. Let's be clear. 220 meters is the position that it ends up at, 220 meters above the ground. This is 400 meters at the top, so what that means is that you've actually fallen 180. So careful about that. Alrighty. Now, here, another question. It says the position of the object is given by this function here, not the acceleration. So the first derivative is going to be 6t plus 1.5. Let's get the second derivative. Ooh, here we go. 6t, second derivative, we're going to get 6 meters per second squared by taking the second derivative. Some people were like, hey, wait a minute, man. This looks like the 1/2 at squared equation plus v naught t plus x naught. Let's just double this. That's pretty cool. You could do that. I'm cool with that. All right. Now, for number 12, you know what? We're going to do that in the next video.